All right, so we've been learning about the periodic table. One of the things I want you to learn about today and think about is the fact that if you go to the grocery store, when you go to the grocery store, like if your mama sent you in to get, let's say you needed to get milk and what kind of drink y'all want to get?
Ginger ale.
Mountain Dew, ginger ale. Okay, so
Sweet tea.
would you go to the same place to get the milk and the ginger ale? No, they're different places, right? They're in different aisles.
Yes.
Why?
Because they're not the same kind of.
Different kind of products, right? I mean, but they're both drinks.
One is like
Ooh, the cooler, the cooler.
Oh, okay. So
cool.
one has to be cooled, right? It has to be refrigerated.
Yeah.
What happens to milk if you don't refrigerate it? Yeah, it goes through a chemical reaction, right? Starts to make bubbles. You ever accidentally, your brother, little or little sister left the milk out and you go to pour it in your cereal and it's chunky, right? All of a sudden, solids have started to form inside the milk. Okay, so you know it's bad. So when you think about going to the grocery store, you have all the things over here, all your lettuce and such as that. Like if I go to Wendy's, all the lettuce, all the fruits, vegetables are on this side, seafood, meat,
Seafood.
milk, right? Everything's running outside edge. If I was looking for drinks, I go to aisle 3. Well, what we're going to learn today is what's some of the logic behind setting up the periodic table. Because when you think about it, you classify all kinds of different things. So you might have a dresser or a chest of drawers at home, right? And one drawer has all your socks in it. One might have shirts in it. One might have shorts in it. One might have whatever, right? So you don't just pile everything into one drawer. You have them classified as to what they do. So when we think about the periodic table, it's the same exact thing. We're classifying elements. So we want to talk about some of the reasoning behind it. So when you think about elements, they're the building blocks of all matter. We know that. Who was the first guy to come up with that idea that all matter is built of indivisible particles?
I remember, but I forgot his name. But I remember talking about it.
Mendeleev.
Mendeleev came up with the periodic table. It was Dmitri Mendeleev, but you think about his name sounds kind of like democracy. Democritus. He came up with the idea that all matter is basically space, but an atom is small, indivisible little particles, is what he said. Aristotle comes along, we leave that, and then Mendeleev comes back around, and we start moving back that direction. And then when we started getting all the formation of an atom, we got there. Now we're talking about an element. Now, Mendeleev came up with the periodic table of elements. But an element is a substance that cannot be broken down and is identified by the number of protons in its nucleus. So when we look at potassium, there's 2 numbers up here. Okay, so we have the name. What does this K stand for? What do we call that? Symbol, right? Atomic symbol. What is this right here? Atomic number. What is this one right here with decimals? Atomic mass. All right, so what does the atomic number tell us?
Wait, no,
How many? Which one calls it got?
How many protons? And protons reside where? Nucleus. Very good. Now, if I wanted to know, now if this was balanced, how many electrons would it have?
19.
19, right? So if it was balanced, it would have protons are what charge? Positive. Electrons are what charge? So if it's balanced, they'd have to be equal, correct? Now it could be an ion, right? Could be an ion. But we're talking about balance right now at this point in time. So how would we determine how many? We know we have protons. We got 19 protons, 19 electrons. How would we calculate the number of neutrons? How do we figure that? Based on this, how can we figure out how many neutrons are in there?
Don't you gotta like subtract?
Subtract what? The what now? you know you got to subtract. All right, which number here is the largest number? The mass. All right, so when we go back, let's think about this. We talked about the makeup of an atom. In an atom, what is the relative mass of one proton? Approximately 1 atomic mass. What is the mass of one neutron? Approximately 1 atomic mass. What's the mass of an electron? 0 atomic mass, right? Electrons are very, very light. But considering the atomic mass, and we know that protons are roughly equal to 1 atomic mass, neutrons are roughly equal to 1 atomic mass. If I know it has 19 protons, it has a total mass of 39.908. If I take the atomic mass minus 19, then what do I have? The answer to what? The neutrons, right? And I learned all of that from right here, just on the element. So we have the name, the symbol, the atomic mass, and the atomic number. Okay, so when you start talking about each element, and it's important to understand what we can learn. When we start talking about the periodic table, we're going to learn what can you learn off of each element. And then we're going to put all that together to learn what the whole table, because there's a whole story that the periodic table tells us. Based on the period and the group that it's in, that lets us know how reactive it is. Okay, so we're going to learn how reactive it is. We're also going to learn how many valence electrons it may have. We're going to learn how many orbitals of electrons it may have around it. And all of that can be seen simply by looking at the periodic table. Also, characteristics of elements can be identified by the periodic table. Y'all remember when Mendeleev come up with this table and he classified all of them and arranged them? He predicted, he had some gaps in the periodic table. What did he predict? There was one gap that was undiscovered, but he called it what? Y'all remember that?
No, I don't.
What did he call it? Remember he called it aluminum. Yeah, aluminum, right? He knew that there was going to be an element found right below aluminum. And what did he say about it? He said it's going to be a metal, right? He also said that it was going to be silvery, malleable, and have a low melting point. Later on we find out, what's the element that we find out and call it later?
Gallium.
Yeah. Yeah. It actually has such a low melting point that it'll melt in your hand. If you put it in your hand, it'll actually turn to a puddle in your hand. You can roll it around.
Where can you get it from?
Well, if you're just going to get it, you would have to order it. You know, a lot of, like some of the companies we get some of the chemicals from that we use in here, you can order some stuff. Now, some stuff we don't have the facilities to be able to handle. Some things like, so, going back to the periodic table, all the way over to the left, you'll never find, okay, so you got the alkali metals, alkaline earth metals. Those are so reactive. When you get to college, you will probably get to be able to work with some of those, but you've got to keep them under oil because they're so reactive, they'll actually react with the air if exposed to it. So they keep it in the oil, they keep it stabilized. So you can see some of that when you get on to college. But for us, we don't have the facilities to have some of those things, but some of those other ones.
At this time, please dismiss all cheerleaders and dance line members from the Skellington's room. Thank you.
Hamza was fixing to go. Okay, very good. So, today, basically, the main thing I want us to get is when we start talking about the breakdown of the periodic table, what we learn from each little element. Okay, what we learn from each little element. What questions do y'all have about that?
About what we just
I have none, Coach.
Good?
We're good.
All right, awesome.